Hey there, MSM3. This is lesson 5 in unit 4. We are going to talk about slope. We've been talking about slope. We just haven't called it slope yet. The red and blue lines on the coordinate plane below show distances two different people can walk over time. For each travel time below, find the distance walked. Record your results in the tables below. Then find the rate that each person is walking by dividing the distance by time. That should sound a lot like the direct variation thing we were talking about in the last lesson. So if we pull data directly from the graph, and you'll notice that I highlighted the blue line in blue and the red line in pink just to make it a little easier. On the blue line, after 20 minutes, so we go over to 20, that person has walked 2,000 meters. 2,000 divided by 20 is a rate of 100 meters per minute. If we go over to 30, the person has walked 3,000 meters, or 3,000 divided by 30 is 100 meters per minute. And if we go over to 40, no surprise, 4,000 divided by 40 is 100. So that means this person has a rate of 100 meters per minute and that their K is 100 because they're really interchangeable, K and the rate. The second person on the red line, if we go over to 15 minutes, you'll know that person has gone 1,000 meters. After 30 minutes, the pink has gone 2,000. And after 45, 3,000. Now, if we divide 1,000 by 15, 2,000 by 30, and 3,000 by 45, it comes out to 66.6 repeating. Not particularly friendly, but we can work with that. So the rate is 66.6 repeating meters per minute, or the value of K is 66.6 repeating. Rate is distance divided by time. That was listed up in bold above. Or we can say in order to get R, you would do D divided by T. Compare your tables. Which person is walking at a faster rate? So the blue line is 100 meters per minute. The pink or red line is 66.6 repeating. So we would say the blue line, 100 meters per minute, is faster than 66.6 repeating meters per minute. How do the graphs show who is walking faster? So what do you notice about the location of the blue line compared to the pink line? The blue line is steeper or higher than the red line. Suppose you had a faster walking rate than the rates we found. How would a line of your distance walked over time compare to the graphs shown? So if you were walking faster than both the blue line person and the red line person, you would have a line that is steeper than both. It would be the steepest. You can write an equation to model the graphs above. Use the model below to write an equation for each of the graphs. So distance equals rate times time. D equals RT should look an awful lot like Y equals KX. Time is the input, or you can say time is on the x-axis. Distance is the output. It was on the y-axis. And the rate is your K value. So the blue equation could be Y equals 100X or D equals 100T. That would be a very similar equation. The red line would be Y equals 66.6 repeating X or D equals 66.6 repeating T. Same idea. On the back, it says the rates that you found for each line is the slope of the line. The slope of a line is a ratio that measures the line's steepness. Slope is also known as rise over run. The rise is how much it changes vertically, and the run is how much it changes horizontally. Vertically is your Y, and horizontally is your X. So if we think about that, it is also the same as saying we took the Y value and divided by the X value, which should look really familiar. That's what we did to find our K value. So K was Y divided by X, or we can say to get the rate, we did distance divided by time. To find the slope of a line using a graph, choose two friendly points on the line. So you'll notice that this line is just that. It's a line on a grid, and it doesn't have any coordinates labeled. So friendly points are going to be on the crosshairs. So this is a friendly point because it falls right on a horizontal and vertical intersection. Another one for this would be at 0, 0. So you might say 0, 0 is one of our friendly points. and 2, 3 is one of our friendly points. So to get from one to the other, we would go up 3, right 2. So that would be a rise of 3 and a run of 2. So our slope would be 3/2. So slope is the fraction 3/2. You don't normally see people say 1.5. They usually leave it as a fraction. We can also notice that it is a positive slope. So slope is 3/2. All right, next one, 2 friendly points. So this looks like it's pretty good on the crosshairs. This is another one that looks like it's on the crosshairs. I would be looking at -1, -1, and this one would be 3, 1. So I would have to go up 2, right 4. So I could say that the rise was 2 over the run, which is 4. But 2/4 isn't in lowest terms, and slope we put in lowest term, or 1/2. So our slope would be 1/2 for this one. Next one, picking 2 friendly points first on those horizontal and vertical crosshairs. That's a good one. That's another good one. I will say, ooh, the first one and the second one were both going up to the right. They were both positive slopes. They both had positive numbers for the slope. This one, however, I have to go down and to the right. You will notice that we are always going from left to right, just like reading a book. So this one is going down 3, right 1, 2, 3, 4. So the rise is actually not a rise at all. It is a down or a fall of 3. So we use -3. And the run is going to the right 4. So our slope would be -3/4. Notice negative slope. And last but not least, we've got to pick out 2 friendly points. Those look pretty good. I'm going to go from left to right. So I've got to go down 3 in order to go right 1. So down 3 being a fall more than a rise, and to the right 1. Rise over run, -3 over 1, which again, we want to go for lowest terms. Best answer would just be a slope of -3, also a negative slope. Graphs that slant up from left to right, those ones come out to have a positive slope. And graphs that slant down from left to right have a negative slope. And the numbers should reflect the same.